A newly discovered Greenland mantle plume drives thermal activities in the Arctic. Well, we've recently been told that the Arctic is warming up much faster than the rest of the world because of the climate change. But something very strange is happening there. Next to Greenland here, with the white area, is Iceland on the west, on the east, and Greenland. We know Iceland has a mantle plume under it. It's a volcanic island, and Greenland has recently been found to have mantle plume as well. The newly discovered Greenland plume drives thermal activities in the Arctic. This is by Tohoku University on Land Manager and Science Daily. Recent findings provide researchers with better knowledge of the melting of the Greenland ice sheet. So that's what's causing it. December 7, Tohoku University, a team of researchers gained a deeper understanding of the melting of the Greenland ice sheet. They discovered a flow of hot rocks known as mantle plume, rising from the core mantle boundary beneath central Greenland that melts the ice from below. Now we know that even in northern Canada we have volcanoes in that area. They're called kimberlite volcanoes. They're diamond spewing volcanoes. We don't know too much about the northern territories of Canada, but I didn't do a video on that, but I did read on that. So, of course, Greenland is just above that area of the northern territories of Canada. Now, the results of their two-part study were published in the Journal of Geophysical Research. They said, knowledge about the Greenland plume will bolster our understanding of volcanic activities in these regions and the problematic issue of global sea level rising caused by melting of the Greenland ice sheet. So it's melting also because of the fact that it's got heat coming out from the volcanic area, the mantle plume underneath. This is by Dr. Genti Toyokuni, co-author of the studies. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. So here we are again with Greenland, Iceland on the east, which is a volcanic island with a mantle plume, and on the west of Greenland we have kimberlite diamond spewing volcanoes of the Northern Territory, the Arctic area of Canada. And this is the air temperature around Greenland. We see that it's quite hot. So this is what they believe is causing the thermal activity there, the rise in thermal activities in the Arctic. So Dr. Genti Toyokuni, co-author of the studies, the North Atlantic region is awash with geothermal activity. Iceland and Jan Mayen contain active volcanoes with their own distinct mantle plumes, while Svalbard, a Norwegian archipelago in the Arctic Ocean to the north of Iceland, is a geothermal area as well. However, the origin of these activities and their interconnectedness has largely been unexplored. Are they connected? Well, it's still unexplored. They're still learning a lot about this. And we have the Svalbard plume, the Jan Mayen plume, the Iceland plume, the Greenland plume. The triangles are volcanoes you have over Jan Mayen and Iceland, and the circle is geothermal area, Svalbard and Greenland. So the research team discovered that the Greenland plume rose from the core mantle boundary to the mantle transition zone beneath Greenland. The plume also has 2 branches in the lower mantle that feed into other plumes in the region. Okay, so we have them there in Iceland, Jan Mayen plume, Svalbard, and that's all from one plume. Okay, Greenland plume, Iceland plume, joining together. The plume also has 2 branches in the lower mantle that feed into other plumes in the region, supplying heat to active regions in Iceland and Jan Mayen and the geothermal area in Svalbard. Their findings were based on measurements of 3D seismic velocity structure of the crust and whole mantle beneath these regions. To obtain the measurements, they used seismic topography. Numerous seismic waves arrival times were inverted to obtain 3D images of the underground structure. The method works similarly to a CT scan of the human body. Toyokuni was able to utilize seismographs he installed on the Greenland Ice Sheet as part of the Greenland Ice Sheet monitoring network. Set up in 2009, the project sees the collaboration of researchers from 11 countries. The US-Japan joint team is primarily responsible for the construction and maintenance of 3 seismic stations on the ice sheet. And looking ahead, Toyokuni hopes to explore the thermal process in more detail. He said this study revealed the larger picture, so examining the plumes at a more localized level will reveal more information. And this was released, published on on Tohoku University website. The map of the P-wave velocity tomography at 5 kilometers depth, that's 3 miles down, beneath Greenland and surrounding regions. Blue and red colors denote high and low velocity perturbations, and respectively, those scale in percentages is shown beside the map. The white dot line are the thermal tracks of Iceland and Jan Mayen plumes, and we see they're into Greenland. And they are affected by the Greenland plume. The area surrounded by the black dots lines where the flow caused by melting the bottom of the ice sheets. So it's all over Greenland, as we can see. Existing northeast Greenland ice stream, its water source is located at the intersection of 2 heat tracks. The vertical cross-section of the whole mantle tomography passing through central Greenland and Jan Mayen, we can see that the Greenland plume is the heat source for the Jan Mayen volcano. Okay, so you see this red area there, basically the eastern part of Greenland. The plume is very, very high up there. Now, the Greenland Ice Sheet is a vast body of ice covering about 80% of the surface of Greenland. It's the second largest ice body in the world after the Antarctic ice sheet. The ice sheet is almost 2,400 kilometers long in the north-south direction. Its greatest width is 1,100 kilometers near its northern margin. The ice sheet consists of layers of compressed snow from more than 100,000 years, contained in its ice today most valuable record of past climates. In the past decades, scientists have drilled ice cores up to 3 kilometers deep, and with the ice cores, scientists obtained information on proxies for temperature, ocean volume, precipitation chemistry, and gas composition of the lower atmosphere, volcanic eruptions, solar variability, sea surface productivity, desert extent, and forest fires. This variety of climate proxies is greater than any other natural recorder of climate, such as tree rings or sediment layers. The Greenland Ice Sheet has experienced record melting in recent years and is likely to contribute substantially to sea level rise as well as to possible changes in ocean circulation in the future. This is according to Science Daily. So please leave your comments. Thank you for your support. This is obviously the mantle plume giving rise to thermal increase in the Arctic, and a lot more has to be done to find out what exactly is going on with volcanic mantle plumes under Greenland. Please leave your comments. Thank you for your support.